So thank you and good morning, everyone. Let me start by saying I'm very pleased to be here. I'm honored to be here and thankful for the Department of Energy and ARPA-E for sending the invitation, but also for doing the great work that they do. So I'm going to take the next 15 minutes to do a couple things. First, briefly introduce you to BASF, who we are and what we do, and then talk about how we think about energy, because we are an energy-intensive company in an energy-intensive industry. But I'll come at it from a different perspective, from the broad perspective of sustainability. Now, BASF is a company. We are in the chemical industry. We're the largest chemical company in the world. We have about $70 billion in annual sales, 120,000 employees, and we're very broad in terms of the product lines that we're in and the markets that we serve. So everything from oil and gas to petrochemicals to high-performance polymers, coatings, catalysts, agricultural protection products, cosmetic ingredients, you name it. And this broad basis that we're in is supported by a rather intensive focus on research and development. So we have about 11,000 R&D personnel in the company, and we spend about $2.5 billion a year on R&D because to us it's the heart of everything we do, and we have to drive this going forward. The photograph you have here on the slide is one of our researchers in our Advanced Battery Materials Laboratory, where we focus on cathode materials for the automotive industry. Now, the business of chemistry for a company like BASF means a couple of things. First is we are fundamentally hydrocarbon-based, if you will. The vast majority of our raw materials for everything we make come from oil or gas-related products. And secondly, we are energy-intensive. So to rearrange or react molecules, you generally need energy in the form of pressure or temperature, and so we are hydrocarbon-based and energy-intensive. But dealing in the physical world, or the world of materials, we would see that likely staying this way well out into the future. So, for example, despite all of the great innovations that are occurring in our company and elsewhere, we would see in 30, 40, or 50 years from now, we will very likely be hydrocarbon-based and quite energy intensive. So we have to find a way to deal with sustainability topics in that framework. And as you can see on this slide here, this is our corporate purpose statement. We create chemistry for a sustainable future. Now, we define sustainability as combining economic success with environmental protection and social responsibility. Now, you might ask, why does a company like BASF put sustainability in its corporate purpose statement? And that's because these topics for society are enormous. Dealing with the issues of energy, food, nutrition, water in the future are big topics. And the good news from our perspective is we think many of the solutions to tackle these problems need some form of chemistry participation. And so we feel we can contribute, and we are rather optimistic about the future. Now, when it comes to sustainability, I think we've always been relatively transparent, and we've tried to set aggressive goals for ourselves, and we've made these transparent to the outside world. But towards the end of last year, we reset some of our sustainability targets, and I think we took a rather aggressive stand with a few of them. Everything from water management to energy topics to how we will control our suppliers and what we demand out of them from a sustainability standpoint, and also how we will focus our researchers on product development that can contribute in a positive way to the world. But I think probably the boldest reset that we made is we suggested that we will grow going forward in a CO2 neutral way. So in other words, we are projecting that we can grow our business by 50% in terms of volumes between now and 2030 and add no incremental CO2 to the environment. So CO2 neutral, very aggressive, and certainly supports the big topic of climate change. And you might ask, why would a company like BASF, where you just described was hydrocarbon-based and energy-intensive, why would we make such a commitment to the outside world? And there's basically two reasons. First one is we have to. We have to. These topics are big. Society will demand that industrial companies like ours do something about it. So we feel we have no choice. We feel like we can make it happen. And the political framework over time will evolve to also demand that we deal with this topic. We want to have a seat at the table. To do so, we have to have credibility, and therefore we need to put a stake in the ground. The second reason we made the commitment is because we believe we can do it. It will not be easy. It will not be for free. It will cost us quite some money, but it's necessary, and we will do it. So how? The how is based on 3 pillars. The first thing is continuing to drive basic process efficiency. This is making more for less in all possible ways. And I think we've had a good track record of doing that. Since 1990, our company has doubled its output in terms of volumes of what we sell. And at the same time, we've cut our greenhouse gas emissions in half. So we have, in absolute terms, reduced it in half. Now, there was a lot of low-hanging fruit there. I mean, this is clear. And it won't be so easy going forward. But the opportunities still exist. As an example, here you see a photograph. This is our largest operating site in the world in Ludwigshafen, Germany. There are literally 150 chemical facilities interlinked in a piping network, all tied together, where products of one plant become raw materials at the next plant. All waste streams, byproduct streams are captured and somehow returned into a process. Exothermic and endothermic reactions are balanced to the best of our ability. We create our own power and steam with combined cycle equipment. And when you put all that together, we estimate that in a typical year like last year, we saved about 6 million tons of CO2 emissions compared to a more traditional way of manufacturing our products. So the opportunities still exist. They'll be tougher to get, but from an operational excellence standpoint, we think we can squeeze out more going forward. But that won't be enough. Process efficiency from a day-to-day incremental improvement standpoint is somewhat limited, and we will have to supplement that simply by purchasing outside power from renewable sources. About half of our CO2 footprint comes from the power that we generate, and the other half fundamentally comes from the chemical processes, and we will supplement over time what we're producing with outside renewable sources. Now, at the current time, this is more expensive than it otherwise would be, and we estimate it will literally cost us tens of millions of dollars per year to do what we need to do here to meet our target, but we will do it because we have to, and we will drive in this direction. And finally, we have to drive long-term fundamental breakthroughs with our process technology from research. And when I say long-term, I'm talking about process development for basic chemical processes that'll take 10, maybe 15 years to commercialize, but we're funding them now. We're funding it in a significant way because the only way to be sustainable from a company standpoint like ours is we have to drive some breakthroughs. I can give you a couple of examples. The starting point for many of our product value chains is a steam cracker. This is where you take hydrocarbons, oil or gas-based hydrocarbons, you crack them into smaller molecules that are your building blocks for everything else we do. This is big equipment. Could cost $1.5 to $2 billion for a new steam cracker to be purchased. It's incredibly CO2 intensive. We're operating at temperatures north of 850 degrees C. These are gas-fired units. So we have an active program with Linda working on electrifying steam crackers and redesigning the furnaces completely, working with new materials that can handle the current flows. But if we can electrify the furnaces and we can purchase renewable power, we could reduce the CO2 emissions by 90% in the most basic process that we operate in the company. Another example is with hydrogen. Hydrogen is also a building block for what we do. Current processes to make it are very CO2 intensive. We have a coalition of partners that have been working for several years on methane pyrolysis to basically take methane, cleave off the hydrogen, leave behind very, very pure carbon that can be marketed to the metals industries, and essentially produce zero CO2 in the process. It will require some energy, of course, but far, far less than traditional ways. And the final example is dry methane reforming. We have some new catalyst packages that will allow us to more economically react CO2 with methane to make synthesis gas, which again is a starting material for us. And from that you can make olefins or ammonia or methanol. All of these processes are at least 10 years away from big-scale commercialization. And this is not easy for a publicly based company that has to worry about short-term financial pressures to be able to invest in the long term, but we feel that it's absolutely an imperative. We have more than 100 researchers dedicated to this long-term basic process development. Now, I've talked mostly about our sort of carbon management concepts for the future within the fence line of BASF, meaning inside the fence line where we produce our products. But we can also think outside the fence line in terms of the products that we make and sell. Many of the products we make and sell can actively contribute towards sustainability challenges like climate control. And we have dozens and dozens of examples. One here I simply show is the whole suite of insulation materials that we have for commercial and residential construction. Our latest offering is called Celentite here. These are insulating materials with nano-scale pore structures that can be made very, very, very thin and still have the same heat transfer characteristics. So we can reduce thicknesses up to 50%, give architects and designers more degrees of freedom to design what they're trying to design and save energy. Another example is what I referred to at the beginning, and this is battery materials for electromobility. We see this as transformative for the automotive industry. The automotive industry is our largest market. We sell about 11 billion euros of products into automotive each and every year. And the world makes about 95 million new cars each and every year. And we project maybe this gets up to something like 105 million cars a year in 2025. But we can also easily imagine 10 to 15 million of those cars each and every year will be electrified by 2025. It's an enormous opportunity. It takes tremendous innovation, strength, and power, and sort of a long-term focus. Our particular focus is on cathode materials, because this is where fundamentally you can drive the energy density in a safe and cost-effective way. And we are investing in this topic literally hundreds of millions of dollars because we see this as being huge, huge for the future. So to summarize, I mean, the sustainability challenges facing society going forward are enormous, including the topic of climate change. And this requires intensive innovation by all of us. This requires bold aspirations. And we believe that chemistry can be a significant contributor. And therefore, BASF can have something to offer. So the future is in our hands, and I would say we are quite optimistic about the future. Thank you very much.